So in hello, hello. Okay. See this. So and so date, so and so product sold to so and so customer. How much quantity sold? One. What the amount sold? 2000. Okay. Then. So this is the table. Next. Same day. Same day. Okay. Then. Same product sold to different customer. Sold to different customer. Possible or not? Yes. The same day, same product sold to different customer. Possible or not? Yes. And same day, different product. That is product 101 sold to customer 11. What is the quantity? 1. Suppose the product is 3000. Same day, this is different product sold to different customer. Okay. Then next one. So next day, 04 Feb 23. Next day, product 100 sold to customer 10. Quantity 1, amount is 2000. Like, so this is the what? Okay, na? This is the table. So this table is given to you. They'll ask identify primary key in this table. Then table is given. Okay, na? Then some data. You see the data and identify what is primary key. Can I take data? Can I take? So what I said, when not possible with single column, try with combination of two. Date ID, product ID, date ID, product ID combination. Can we take this combination as primary key? No, because this combination is yes, no, not February 300. This combination is also the combination that not possible with combination of two. Then combination of what's 3. Can combination as primary product ID is what? Primary key. What is this is composite primary key. Okay, na? Is given. What that is? Identify. Okay, na? Identify primary and write create table script. Identify primary key and write create table script. Hmm. Hmm. So identify primary key, write create table script. ఆన్లైన్ వాళ్ళకి వాయిస్ బ్రేక్ అవుతుంది అంటున్నారు.
అని ఈసీరా వేరే ప్రాబ్లమ్స్ అదే వేరే
ఓకే. ఓకే దెన్. Now, so in this table, identify the primary key and write create table script. I written now this create table. This is the registration table. Okay, then okay. Now the same like previous example. Next one. Okay, then let's see composite foreign key. Composite foreign key. Then if foreign key declared for combination of columns, then it is called composite foreign key. If foreign key declared for combination of columns, then it is called hello, please pass. If disturbance is there, I cannot teach. You want to talk, please go out and talk, please. You listen the class. You discuss after the class. You listen. Please listen the class. So then, if foreign key is declared for combination, then it is called composite foreign key. If primary key is declared for combination, composite primary key. Similarly, if foreign key is declared for combination, then it is composite foreign key. Actually, a foreign key refers what? Foreign key refers primary key. A foreign key refers primary key of another table. Yes or no? You declare foreign key na references. A foreign key refers primary key of another table. A composite foreign key refers composite primary key. Understood? A composite foreign key, what? A composite foreign key references what? Composite primary key. Foreign key refers primary key. Composite foreign key refers composite primary key. If foreign key is composite, the primary key must also be composite. Now, okay, then. Now let's see. Sir, actually, just listen. First, listen this. I taken this example. This is the table I have taken. Listen. Next, there is a table. What the table is, you already know, registrations. In this table, what is primary keys? Student ID, course ID is primary key. And students completes course. After completing the course, a certificate is issued to the student. After completing the course, a certificate is issued to the student. What is the certificate number? Date of issue. What is the certificate number? And the certificate is issued on which date? Certificate number is 1000. It is issued on so and so date. Maybe someday, like 2nd Feb 23. It is issued on so and so date. If these details are enough, certificate number, date of issue is enough? No. I'll ask, this certificate issued to which student? I'll ask, this certificate is issued to which student? Can you answer? No. Then what should be there? What should be there? Student ID. Student ID should be there. I entered the student ID 1. That means this certificate is issued to student 1. Student 1. Okay. Then next. And here, but I'll ask, by completing which course this certificate is issued to the student? What should be there? Course ID should be there. Okay. Course ID. Course ID is what, sir? 10. Course ID is 10. Now the complete details are there or not? Yes. What is the meaning? So and so student completed so and so course. By completing this course, a certificate is issued to the student. This is the certificate number. It is issued on so and so date. Understood or not? Now, complete details are there. Now, let's say 1001, so and so date, and student 1, 11. What is the meaning of this? Student 1 completed course 11. By completing this course 11, a certificate is issued to the student, so and so date. 1002, so and so date, student 2, like course 11. What the meaning is, student 2 completed course 11. By completing this course 11, a certificate is issued to the student. Okay, na? Then tell me, so this is valid or invalid? This is valid or invalid? So this is valid. Yes, student 1 completed course 11, you issue the certificate. Student 1, 11 completed the course, you can issue the certificate. So this is valid or invalid? Invalid. This is invalid. Student 2 is not completed course 11. Student 2 is registered for what? Course 10. Is not registered for course 10. When is not registered for course 10, so you cannot issue the certificate. This is valid or invalid? Invalid. Student 2 is valid. Student 2 is valid. Yes. Course 11 is valid. Yes, actually course 11 is also a valid course. Student 2 is also a valid student. What is wrong? Combination is wrong. What is wrong here? Combination. 110 valid combination because he registered. 111 valid combination registered. 211 invalid because he registered for course 10. Is not registered for course 11. When he is not registered for course 11, you cannot issue the certificate. So what this is? This is what, sir? Invalid. Then tell me, what is the rule here? What is the rule here? SID, CID combination should match with, sir, this combination should match with registration table primary key. Yes. So 110 is matching, valid. 111 matching, valid. 211 not matching, not valid. Understood? So whatever combination we enter here, this combination should match with this combination. That means this combination must be declared. This combination must be declared. Sir, remember here there is no confusion. See, one column value should match with another table primary key. Then declare foreign key. So this column value should match with this primary key. That means this combination should be declared. foreign key. So this foreign key refers this primary key. So foreign key is for single column or combination. Then it is called composite foreign key. Okay. Then so now in the above example, SID CID combination should match with what's that? Registration table SID CID combination. Okay. So then declare this combination as what? Foreign key at what's that? Table level. Okay, now then. Okay. Now okay. Then next. Oh. Sir, registration table is already created. Already there, na registration table. Now we create what? Certificates table. Already registration table is created in the last class. Create table what? Certificates. Then one is certificate number. Number 4. In certificates table, certificate number is certificates table. Certificate number is primary key. Certificates are uniquely identified by certificate number. So certificate number is primary key. Date of issue, date, SID, number, what's that? Number 3. SID number 3. SID is foreign key. SID is foreign key. Is SID foreign key? No, that's all. SID is not foreign key. Course ID is not foreign key. What is foreign key? Combination is foreign. SID is not foreign key. Course ID is not foreign key. Combination is foreign. SID number 3. Next, comma. Course ID number 2. Then comma. That means you declared all the columns. Okay, na? Next, declare foreign key. We have to declare the foreign key at table level. Why? Because this is not for single column. This is for combination. Then how to declare that? Okay, na? Then once again, listen this. So you declare like this. I want to declare this combination as what? foreign key. Then you say like this, what is foreign key? SID comma what? CID. That means I'm telling Oracle that I'm declaring this combination as what? Foreign key. Declaring this combination as foreign key. This foreign key, but when foreign key is there, compulsory references must be there, because foreign key always refers some table primary key. Then what? References, and this foreign key should refer which table primary key? Registration table primary key. Yes. Then references what? Registrations table SID comma CID bracket close semicolon. Okay. Then so I'm declaring this combination as foreign key. This foreign key references registration table primary key. That's all. So let me create this then. Okay, then. Okay, now. So let me run this. Let me execute this then. So after executing this command, a relationship is created between the two tables. Which two tables? The registrations table and certificates table. In this, who is parent, who is child? Primary key table is parent, foreign key table is child. What is the primary key table? Registration table combination is primary key. Certificate table, this combination is foreign key. So this is parent table. This is what? Child table. So let me create this. Create the table. Okay, na? Let me create the table. So table is what, sir? Created. Then next, after creating the table, okay, na? Relation. You want to test it. If you want to test, insert the data. Sir, when after declaring consents, you want to test, insert the data. So insert the combination which is not there in the table. In registration table, what combination is there? 110. Next one, 111, like this. If you want, you can see select star from what? Registrations table. I think data is not there. Okay, na? Then what you do? You do one thing. Okay, then you enter the data which is not there in the registration table. Enter the combination which is not there in the registration table and check accepted or not. Okay, then that's all. So this is what? Composite. Sir, in this we declared check constraint at table level. We declared primary key at table level. We declared foreign key at table level. Okay, na? We declared primary key at table level, foreign key at table level, check consent at table level. Okay, then. So, like, one question is like this: which of the following constraint cannot be declared at table level? Which constraint cannot be declared at table level? A, unique. B, check. C, not null. D, primary key. E, foreign key. Sir, 1 second. One constraint cannot be declared at table level. One constraint cannot be declared at table level. All constraints can be declared at column level. One constraint cannot be declared at table level. Which constraint? Unique. What is the answer? Which constraint cannot be declared at table level? Okay, na? Huh? Not null. Huh? Sir, once again, listen, see, by yourself you can find out easily. Sir, I given three examples. Table level, I given three examples. What is the first one? Check. That means answer is not check. Check we have seen practically we declared the check consent at table level. Primary key we declared table level. In the previous example, foreign key declared at table level. So answer is there between only two. Okay, I not given example only for two. What are the two? Unique and what, sir? Not null. And one simple logic is when primary key is possible, unique also possible. When primary key is possible, what, sir? Unique also possible. Answer is what? Not null. Not null constraint cannot be declared at table level. Not null is always declared for column level. Not null is always declared at column level. Not null cannot be declared at what, sir? Table level. Oh. Oh. See that this is primary key, that's all. Okay, na? Even the internally functionality wise it is combination, but primary key is one constraint. Okay. Not null is declared only for single column. You cannot declare this not null for multiple columns, combination. Okay, na? Not null constraint cannot be declared for combination of columns. So answer is not null. Okay, then. Just a minute. Oh. Just see this once again. Now, then there is a question like this. Okay, na? Then there is one question. Which of the statements are true regarding constraints? Which of the statements are true regarding constraints? What is that is? Foreign key cannot contain null value. Foreign key cannot contain null value. That is a statement. You have to say that statement is right or wrong, true or false. Foreign key allows null values or foreign key doesn't allow null values. Foreign key allows null values. Foreign key allows null values. Then this statement is right or wrong? Wrong. False. False. A column with unique constraint can contain null value. Unique constraint allows null value. That is his statement. Yes or no? Yes. True. Unique allows null values. Unique constraint allows null values. All this we have seen practically. You just go and check. Okay, na? Then next one. A constraint is enforced only for the insert. constraint is enforced only for the insert. What is the meaning? Meaning is Oracle checks the constraint only at the time of inserting the data, not at the time of updating the data. That is the meaning. Oracle checks the constraint. Suppose check constraint is there. Oracle check the check constraint only at the time of inserting, not at the time of updating. That is the meaning. False. Oracle also checks at the time of update. Can you update the primary key to duplicate value? No. Can you update the primary key to duplicate value? No. So Oracle also checks at the time of update. Not only for the insert, it has also checks for update. Next one. All constraints can be defined at column level and table level. All constraints can be defined. False. Because which one? Not null. Not null cannot be declared at table level. Okay. Na? See, listen. Which statements are true? A foreign key cannot contain null value, but foreign key can contain null value. This is wrong. A column with unique constraint cannot contain null. Can contain null. Yes or no? Yes, unique allows null values. A constraint is enforced only for the insert. No, not only for the insert, it is also enforced for update. All constraints can be defined at column level and table level. Then false. Understood? Next. So just some examples like, okay, then. Oh. Sir, instead of otherwise you take pick better instead of writing. I'll add it to the Google Class. I'll add it to the notes. Huh? Oh, okay. Then. So, next. Okay, now. Then, for example, next. Oh. There is one. Just see this. One is there. What that is? Which create table statement is valid? Is asking find the what create table, valid create table statement. Okay. First one is valid or invalid? Invalid. Why? Two primary keys are there. Table allows only one primary key. Then what about second one? What about the second one? Invalid. Why? Sir, you can declare two constraints, no problem, but constraints should be separated by space, not by comma. You can declare two, no problem, but they should not be separated by comma. They should be separated by space. Next one, order details. Order details. Then, so this one, third one, like this is limit constraint. This is name limit. Next. Then. This is correct. Valid or invalid? Invalid. Why? This is okay. There is no problem here. Sir, here, 1 second. You know default? You know default? You are declaring default, but default must be compulsory declared with a value. When you are declaring default, default should be declared with a value. You see the previous, our example, how you declared hire date, default, sysdate. You declare like this. That means default should be declared with some value. But you are declaring default, but default is not declared with any value. Then valid or invalid? Invalid. Then now What about this D? Order date, default. What's that? Sys date, not null. Primary key, order number, comma, item number. What this is? Primary key, order number, comma, item number. Composite primary key. This is valid or not? Yes. This is composite primary key. Your default is declared with what's that? Value. Yes or no? Yes. So why A is wrong? Two primary keys. Why B is invalid? Consigns are separated by comma. Why C is invalid? Default is not declared with value. So D is valid statement. That's it. Sir, okay now? Then. Okay then. Now, okay. But if you see these examples, sir, if you see these examples, in all these examples, you added the consign, you declared the consign. But when you declare the consign, you declare the consign at the time of creating the table. Yes or no? But table is already there. I want to add consign to the existing table. You understood the point? We declare the consign while creating the table, but my table is already there. I want to add consign to the existing table. Okay, na? Then. So then how? Now, let's see adding what? Consigns to existing table. Then adding consigns to existing table. Not at the time of creating the table. After creating the table, I want to add consign. Sir, listen. These rules are fixed or changes time to time. Sir, we are declaring rules, business rules. In companies, there are some rules. Okay, na? We are declaring the rules. Okay, there are some rules in the organization. We are declaring the rules in the database. So these rules are fixed or changes time to time. Changes time to time. These rules are not fixed. Yes or no? Rule changes what, sir? Time to time. Okay, na? There is a minimum, like listen, there is a minimum salary 3,000. You declared the rule. Minimum salary 3,000. After some days, some months, some years, company is not doing well. They cannot pay minimum 3,000 salary. They don't want to continue the rule. Then what? Then remove the constraint. Yes or no? Remove the constraint. Next. Suppose there is a started. One organization is started. They started. Okay, na? After some months, some years, they want to declare a rule. Minimum salary should be 3,000. Then what? Add. Okay, na? What do you have to do? Add a constraint. So sometimes you want to add constraint. Sometimes you want to drop constraint. How to add the constraints? How to drop the existing constraint? Okay. Then, so for adding constraint, which command we use? So table is already there. Just you want to add the constraint. Then update is data bus. Update. What is update? Update is data. Then what the command is? Alter. Then so alter. Okay. Alter command is used to add what? Constraints to what? Existing table. Not the new table. Table is already there. Then and example, create table EMP77. One field is EMPNO number 4. One field is ename varchar 210. One field is salary number 7. One field is DNO. Number 2, I created a table, but in this table, no constraint is there. I have not declared any constraint. Sir, okay, na? Create table. I created that. I'm creating the table without any constraint. How? So table is what, sir? Created. Table is created. Next. After creating the table, okay, na? After creating the table, then what? Now I want to add constraints. First, let's see adding primary key. First, we'll add what's that? Primary key. Then I want to add primary key. To which column I want to add primary key? Employee number. I want to add primary key to employee number. But what the syntax is? Alter table name. Add what's that? Add primary key. What do you want to add? Primary key to brackets. Which column? Which column? Column 1, column 2, like this. So this is the syntax for adding primary key. Example. Okay, then. Now, add primary key to EMP Envo. Add primary key to EMP Envo. Then what? Alter table, what's that? EMP add what? Alter table EMP add what? Primary key brackets EMP Envo. Sorry, what is the table name? EMP 77. Table name is EMP 77. So in this table, we are adding a primary key to EMP Envo column. Sir, okay, na? Then you're adding the primary key. Table is what, sir? Altered. Primary key is added or not? Yes. You added the primary key after creating the table or while creating the table? After creating the table. Okay, then. And so listen, if column already contains duplicates, can we add primary key? No, we cannot add primary key to the column that already contains duplicates. In EMP Envo, now at present this table is empty. You added primary key. But if column contains duplicates, then you cannot what? Add primary key. To add primary key, first remove the duplicates. First remove the duplicate, then add primary key. Sir, understood now? Then. So that's all. This is simple. Adding primary key. Just execute this command. Sir, okay? Then. Next one. What is the next one? Adding what? Adding check constraint. Adding check constraint. Adding the check constraint. What is the syntax means? Same. What? Alter table name. Then add what? Check Then alter table, table name, add check. Then, sir, in primary key, what you declare column? Because you add primary key to the column. But check consigned is what? In check consigned, what we write? You write what, sir? Condition. In check consigned, you write condition now. Check consigned is always declared with what? Condition. Then here you have to write condition. Now, sir, if it is a primary key, you mention the column name. To which column you are adding the primary key. But in case of check consigned, you have to write what? Condition. Now, let's see. Here, see this. What, like, suppose, then, add check consigned with condition salary should be greater than or equal to 3,000. I want to add check consigned with condition salary should be greater than, minimum salary should be 3,000. Then how? Alter table what? EMP 77. Add what? Check. Then salary greater than or equal to 3,000. Okay. Then, so after executing this command, check consigned is added to table. Okay. Check consigned is added. Table is altered. Check consigned is added or not? Yes. Okay. Check consigned is added with its condition. Next. Now, suppose now I want to add, listen, I want to add check consigned to EMP table. I want to add check consigned to what? EMP table. Listen this. See, I'm adding check consigned to EMP. This is the EMP table. E-name, salary from what? EMP table. This is the EMP table. I want to add check consigned to the EMP table. Then alter table EMP, add check. What the condition? Salary should be greater than or equal to 3,000. Okay, na? I'm adding the check consigned. What this command gives? Error. What it is saying? Cannot validate. Check consigned is what? Violated. Check consigned is violated. Okay, na? Then, now what is the meaning? What is the meaning here? The meaning is, sir, here you see the table. In table, the employees' salaries are what? Some employees' salaries are what? Less than 3,000. Already employees' salaries are less than what? 3,000. So that's why it is not adding. It is giving what? Error. Some of the employees' salaries are less than 3,000. That's why you are not able to add check consigned. Yes or no? That means, listen, while adding the consigned, Oracle is checking the existing data or not checking the existing data? Oracle is checking what, sir? Existing data. If existing data satisfy the condition, consigned is added. If existing data doesn't satisfy the condition, consigned is not added. Sir, understood? That means while adding the consigned, Oracle also checks what? Existing data. If existing data satisfy the condition, consigned is added. But some of the values are not satisfying the condition, consigned is not added. Understood? Sir, okay, na? But what is my requirement is? My requirement is, sir, I want to tell Oracle. Okay, na? Then listen, actually, one scenario is like this. Company started. One company started. Employees are what, sir? Recruited. So salary with 1,000, 2,000, 1,500, 2,500. Employees are recruited. After some years, they want to implement a rule. Minimum salary should be what? 3,000. They want to implement a rule. Minimum salary should be 3,000. But they don't want to apply this rule for existing employees. They want to apply this rule for new employees. Understood the point? I don't want to apply this rule for what? Existing employees. I want to apply this rule for new employees. Then you tell Oracle that don't apply this rule on what? Existing data. Apply this rule on what's that? New data. Then how to tell Oracle? You have to add like this. See, listen. Alter table EMP, add what's that? Check salary greater than or equals to what? 3,000. Then what you have to tell Oracle? Don't check what? Existing data. Don't check the existing data. Check only the new data. If I insert a new record, check. But existing data, don't check. Then how to tell Oracle? You have to use one option. What that option is? No validate. If you use no validate option, then Oracle will not check what? Existing data. It will check only the new data. Now see this. Now consent is added or not? Yes. Sir, understood? Then now see, note down this. Then what I'm doing is same thing. I'm adding it to what's it? EMP table. What this command gives? Error. Because then the above command gives error because because some of the employee salaries are what? Less than what's that? 3,000. Because some of the employee salaries are less than 3,000. Okay, then above command gives error because some of the employee salaries are less than 3,000. So while adding constraint, Oracle also validates what? Existing data. Okay, then. So there is an option. What that is? No validate. No validate. Okay, na? Then like let's see. So this is okay, na? EMP table. I'm executing this command on EMP table, but in EMP table, some of the employees' salaries are what's that? Less than 3,000. That's why this command gives what? Error. Next to no validate. If check constraint is added with what? If check constraint is added with what? No validate. Then what? If check constraint is added with no validate, then Oracle, what's it? Oracle, what? Oracle doesn't validate what? Existing data, and it validates only what's that? New data. And it validates only new data. Then what? Then you have to use one option. What is that option? No validates. Okay, next. And this can be used. No validate can be used only for the check consigned. No validate can be used only for the check consigned. And you cannot use this for other consigns. Sir, you cannot use it for primary key. You cannot use it for foreign key. You cannot use it for other consigns. You can use it only for check consigned. Understood or not? Sir, don't think that. So a column already contains what? Duplicates. A column already contains duplicates. By using no validate option, I can add primary key. Not possible. So you can use no validate only for check, not for primary key, foreign key. You cannot use it for other constraints. Okay. Then. So that's all. Now you lent two. What are the two you lent? Adding what? Primary key. Adding what's it? Check consign. In check consign, there is an option. What that option is? No validate. What the next one is? Adding what? Foreign key. Adding foreign key. Okay, then. Oh, see, I want to add foreign key to DNBO. I want to add foreign key to what's it? DNBO. Sir, listen. In this table, like, what are the fields? This is the table now, EMP 77 table. In this table, one field is what? EMP NBO, E-name, salary, DNBO. You added what? Primary key. You added what's it? Check consign. Now what do you want to add? I want to add what? Foreign key. Suppose I enter what's it? Department number. Listen this. I entered the department number. I entered some department number. Okay. Then I entered some department number. But this department number is a valid department or not. Okay. Na? I want to check this department number is what? Valid or not. Where is the valid departments are there? The valid departments are there in what's it? Where are the valid departments? The valid departments are there in department table. Select star from what? DEP. Where are the valid departments? Valid departments are there in what? Department table. So here, what should be the department number? 10. 10 is okay. Yes. If you enter 10 means employee joined in accounts department. If you enter 20, it is a valid. That means employee joined in the research department. You enter 30 means valid. Sales. You enter 40 means operations. So 10, 20, 30, 40 is valid or not? Yes. I entered 90. 90 is not a valid department because there is no department called what? 90. When 90 is not there, employee cannot join in 90 department. So this department number should be a valid department. Where are the valid departments are there? Department table. That means this department number should match with department table department number. So then declare this department number as foreign key. Okay, na? Then. So now add foreign key. How to add? Same. Alter table. What? Table name. Next one. Add what? Foreign key. Brackets. What? Column name. To which column you are adding the foreign key? You are adding foreign key to which column? Next one. When foreign key is there, compulsory what must be there? References must be there. Foreign key always refers some table. Table name. Then next column name. So this foreign key refers which table? Primary key. The table name and column name. So for all syntax is not same. Syntax is what? Different. Primary key, check and sign. In check and sign, you declare the condition. Primary key just column name. Foreign key column name. But what is that foreign key? References. Okay. Then small difference, syntax. Then what is the example? What is the example? Add foreign key to what, boss? DNO. Add foreign key to DNO. Add what? Foreign key to DNO. That matches with what? That matches with department table primary key. That is what? Department number. In department table, what is primary key? Department number. Understood? Then add foreign key to DNO. That foreign key matches with department table primary key. Then what? Tell me the comment. Follow the syntax. That's all. Here, alter table EMP77. Then add what? Foreign key. Which column? Which column? DNO. You're adding foreign key to this DNO. Yes. Then add foreign key to DNO. Then next, references. This foreign key should match with department table primary key, department number. Yes. References what? Department table, department number. Department table, department number. Then after executing this command, foreign key is added. That means a relationship is created. A relationship is created between the two tables. Which two tables? Employee 77 and department. In that relationship, which child, who is parent? Employee 77 is child. Department table is parent. So this is child table. This is parent table. Then understood? Now let me run this then. Sir, what it is saying? Once again, it is just giving error. What it is saying? You understood the error? What is the error? No matching unique or primary key for this column list. That means in department table, department number is not declared what? Primary key. Sir, okay na? Understood? Foreign key refers primary key na, boss. In department table, department number must be primary key. Maybe it is not primary key. That's why it is giving what? Error. Then first, first make the department number as what? Primary key. How? Alter table DEPT, add what? Primary key. Then department number. In department table, department number is made what, sir? Primary key. Now after making this as primary key, now you can declare this as foreign key or not? Yes. Now let me run this command. Now this is accepted. Table is what, sir? Alter. Now it is added. Understood or not? Sir, if it is primary key, okay. But if it is not primary key, first, so declare this department table, department number as primary key. Then add foreign key. Sir, understood now? Then you don't need to write this. If you get this error, then add primary key. Understood? Okay. Then, three. One is adding primary key, adding what? Check and sign, and adding what, sir? Foreign key. Okay. Then. So unique. How you add unique? Same like what? Same like what, sir? Primary. Unique brackets column name. Unique brackets column name. To which column you want to add unique? So in bracket that column name. Okay. Next, not null. Listen, not null. So one second. I want to add not null to ename. I want to add not null to what? Ename. Ename should not be null. Nulls are not allowed into ename. Ename should not be blank. Name is compulsory. Okay, na? So don't allow the nulls into ename column. Okay, I want to make it not null. Then actually, sir, for primary key, what is the option we are using? In alter command, what is the option we use? Add. For check consign, add. For foreign key, add. For all consigns, what is the option we are using? Add option. Add primary key, add check consign, add foreign key. Yes or no? But for not null, we don't use add option. We use modify. Listen, we don't use add option. We use what? Modify. Why? Because see, sir, by default, every column is declared with what, sir? By default, every column is declared with what? Null. Internally, every column is declared with what? Null. Null allows, null constraint allows, null constraint allows what? Null values. Null constraint allows null values. Not null doesn't allow null values. By default, every constraint is declared with what? Null. That null constraint allows what? Null values. So that means into this ename, nulls are allowed or not? Yes. Now I want to change that null to what? Not null. That means we are not adding the constraint. We are changing from null to not null. That's why what option we use? Modify. Understood? Then. So what this is here? Sir, we are not adding not null. We are changing from null to not null. The column is already declared with what? Null constraint. So we are changing it to what? Not null. Oh, let's see. Okay, na? Then so next. Then what? So like what the syntax is? Then altered table, what? Table name. Next one, modify. What? Modify. What? Column name. Next one, not null. Which column we want to modify? That column name. Next, not null. So example, modify the column ename to not null. Modify the column ename to not null. Then how? How means alter table emp77, modify what? Ename. Next what? Not null. So after executing this command, so this ename is changed to what? Not null. Okay, then that's all. So run this command, execute this, and so this column is changed to what? Not null. Table is altered. So column is changed to what, sir? Not null. That's all. Okay, now then. See, update is data. Data. Okay, na? Then you want to change the salary, you want to change the commission, you want to change the name, you want to change the job, then update command. Data. If you want to change the data, update command. We are not changing the data. We are adding the constraint, removing the constraint like that. Then not update command. Okay. Then. Sir, okay now? Then. So this is what this is? Adding constraints to what's it? Existing table. So like we are adding what? Primary key, added primary key to EMP Anbo, added check constraint with condition salary greater than or equal to 3000, and added what's that? Foreign key to DNO. That foreign key refers department table primary key. Next, we changed this column ename null to what? Not null. Okay, that's it. So this is how to add. Okay, na? Then. So in EMP 77 table, suppose you added some number of constraints. Okay, na? Today you remember the constraints. Like tomorrow or after 1 week, after 10 days, after 1 month. So will you remember these constraints? Means which table, which constraints are declared? Can you remember? No. My database contains hundreds of tables. In hundreds of tables, can you remember which table, what constraints you declared? No. Okay, na? Then. So how to get this information? Okay, na? I want to get this information. Which table, which constraints are there? Sir, here, this information means this constraints information. This constraints information is maintained in one table. What the table is called? User underscore constraints. So whatever constraints you declared, all these constraints information is maintained in one table, stored in one table. What the table is? User underscore constraints. So you can go to this table, you can find out in which table you declared what constraints. Okay, na? So what constraints are declared in what table? So you can go to this table, you can find out. What this is? This is table, but this table is created by Usera, created by Veracula. It is provided by Oracle. It's not created by user. EMP table, department tables are created by user, but this table is not created by user. This is called system table. What this table is called? System table. This is a system table that stores information about constraints declared in a table. Okay, then so stores information about the constraints declared in a table. So you want to find out what constraints are declared in what table, just go to this table. Okay, then now this is the table. How to see the table? Sir, once again, see here, if any system table is there, don't say select star from. Sir, if you say select star from what? User underscore constraints. It will go like this. That's why then don't run that query. Select star from. Okay, na? Then. Sir, okay na? Then why it is showing like this? See the table. How many columns are there? You see that bars? Sir, what is the describe command will show? You don't know describe? You don't know? You know, no? Describe what? Describe EMP. What it is showing? EMP table structure. Structure means columns. It is showing the columns of EMP table. One column is what? EMP and one column is e-name, job, manager, height. Like that. Like that. Here, one column is what? What are these? These are all columns. Describe EMP is showing the columns now. Columns of EMP table. What are these? Columns. Columns of user underscore constraints table. One column is there. What that is? Constraint name. One column is there. Constraint table. Table name. Which table you declare the constraint? Search condition. Like this. Sir, understood? Now, I want to see the list of constraints. Sir, I want to see the employee names. Then tell me how you write the query. You want to see the employee names, boss. How you write? Select e-name from EMP. I want to see the constraint names and constraint types. Then select constraint name, comma, constraint type from user underscore constraints. Not all the tables. EMP 77 table. Then, sir, once again, you write query. Just once again. You said like this. Select what? Constraint name, constraint type from user underscore constraints. But this query gives one particular table, all the tables. All the tables. My database contains 20 tables. All the 20 tables constraints information is displayed. But I don't want all the 20 tables. I want only one particular table, EMP 77. Then, where condition. How to write where condition? Where table name equal to EMP 77. Then, what do you have to write? Where table name equal to EMP 77. What this gives? This will not give constraints in all the tables. This gives constraints in only one table, EMP 77. Okay, now? Then, so let me run this command. Then it is showing like this. Sir, once again, see that it is going to the next column. Okay, na? It's not showing it in one row. It is going to the next. Why? Because, sir, here actually, what is this? Once again, you see this. What is the constraint name is? Varchar 2. How many characters? 128 characters, boss. That is why next data is coming to the next line. How much width is allocated? Constraint name size is 128 na. That's why, so it is next data. Next data is coming to the next line. That is the problem. You do one thing, but reduce this width. Just in display, not in the table. Just only for display purpose, reduce the width. I don't need this much width. Just I need only 10-20 characters. Enough. Yes or no? Then how to reduce what? Column. Which column? Constraint name. Say format what's that? A20. A means alphabets. How many alphabets? 20 alphabets. What is the size of constraint name? 128 bars. Actually is what? 128. Just for display, I am reducing the width. How much? A20. A means alphabets. How many? 20. Now, run the query now. Now, run the query. Same query. Now, you see that. Constraint name is How many? 20. Width changed to what? 20. Display purpose, boss, not in the table. Table remains same. Only just but display purpose, I reduced the width. How much? I reduced the width to 20. So when width is reduced, then this is second column. Second columns are displayed in the same line now, next line now. Same line. But in previous, what? Second column. Consign type is going to the next line. Consign type is going to the next line. Why? Because of what? Consign name. So this much width is allocated for consign name. That's why consign type is going to the next column. So reduce the width. I reduced the width. After reducing the width, then consign type is displayed in the same column. Yes or no? Just 1 second. Listen. What is P means? What is P means? Sir, SYS C007806 or C007798. What is this is P? P means primary key. R means foreign key, references. C means check consign. C means not null. P means primary key. R means foreign key. C means check. C means not null. So consign type. For consign type, it is giving the code. Primary key, what is the code? For primary key, what code it gives? P. Foreign key. R. Check consign. C. Not null. C. Unique. U. But unique is not there in our table. If it is there, then it will show U. Code U. U is for U. U is for unique. Okay, na? Then what is the confusion here? For both consigned, it is giving what? Same code. Check and not null. For check and not null, it is giving the same code. Then how to identify which is check, which is not null. Okay, na? So we'll see that in the next class. That is on Monday. Okay, na? Then Monday, this will be completed. Consent topic will be completed. We can start another topic.